Hello guys, and welcome to this tutorial on macros. As you can see, it says macros for NASM. That is because this is specific to the NetWide assembler. The syntax for macros differs by assemblers. It's specific to your assembler. So that means that this tutorial is specific for NASM. What is a macro? A macro is a single instruction that expands into a predefined set of instructions to perform a particular task. For example, if I write the instruction exit, that when the program actually gets compiled, you might see the word exit in my code. When the program's actually compiled, that gets automatically converted into those three lines of code: move RAX60, move RDI0, and syscall. So the exit is automatically expanded into a predefined set of instructions to perform the task of exiting. So when you define a macro, you put %macro, you put the name of the macro, argc, which is the amount of arguments it takes, then you have the macro body, which is the actual definition of the macro, the actual code that will get inserted there, and then you put %end macro. So here's an example with the exit macro. We have the name up here, so we got %macro, then exit. Then we have the argc, the amount of inputs for this macro, which is 0, because exit doesn't require any inputs. Although you could have one input for the error code, but in this case, I'm not doing that. So then you have the definition. So the definition here is just the 3 lines of code it'll be replaced with when you use the keyword exit. So argc is the number of arguments that the macro takes. The arguments are inputs that can be passed into the macro. Within the macro body, these inputs are referenced using %1 for the first, %2 for the second, etc. So here I wrote a print digit macro. And as you can see, at the top of the code over here, we got the exit macro again, but then I made a print digit macro. And as you can see, I put 1 instead of 0. That's because this takes 1 argument. So what I do is I move into the REX register %1, because like I said, that lets you get your first input. Then I call print REX digit. So I've made these 2 macros. So now in my actual code, I just got to write print digit 3, print digit 4, and that will actually print 3 then 4. Then I write exit, and that'll exit the program. That's because when I write print digit 3, when this is compiled, it's actually going to be expanded to these 2 lines of code. But since I said there was 1 input, the %1 will be replaced by this 3. And in this case, the %1 will be replaced by the 4. So for the exit macro, argc 0 because it takes no arguments. We use print digit and code underscore start. We specify a number after it. That is our first argument. When we use the exit, we specify no numbers because it takes no argument. If the amount of arguments you have is greater than 1, then a comma is used between inputs. As you can see, I made another macro, print digit sum, and this will just add together the 2 digits you pass in and print that out. So if you pass a 3 and a 2 in, it'll pass 5. But see, since this has 2 inputs, I put a 2 here for the argument count. And then, so I move into REX %1, in this case is 3, then %2, which is in this case is 2, and then I add them together, then I print the digit. So local labels and macros. As we've learned, macros are expanded upon compilation into predefined code. If that code contains a label, this can cause a duplicate label error if the macro is used more than once. So as you can see, I just defined a macro called freeze that just defines the label loop, and then it jumps to the loop. Now, you don't want to actually freeze your code, but this is just an example. And as you can see, in start, I call freeze twice. Now, when this is actually expanded out, the 2 freezes will be expanded out into underscore loop, jump loop, then underscore loop, jump loop. So as you can see, you have underscore loop twice. This will give you a duplicate label error, but it's specifically called, the compiler will call it a redefined symbol error. The problem is solved using 2% signs before label names within a macro. This will make it so that the label is unique every time it is expanded. So as you can see, I just changed the underscore loop to %% loop. You can also change it to %% underscore loop, %% underscore loop, but just personal preference, I like to remove the underscore. And as you can see here, I also changed it, so jump %% loop. So every time after this you use the freeze macro, every time it expands it out, this %% loop will actually be unique every time. So it won't be underscore loop. You could think of it as underscore loop 1 the first time you use the freeze macro. The second time it'll be underscore loop 2, then underscore loop 3. So using %% loop prevents the redefined symbol error because the label is unique every time you use the macro. And I also want to talk about EQU. EQU is used for defining constants for future use. So here's our hello world code, and all I've done here is remember how the hello world code, the 60 down here is our ID for the system exit, and then the 1 up here is the ID for the system write. Then we move into RDI. Remember, 0 is stdin, your standard input, 1 is your standard output, 2 is your standard error. And all I've done is define these up here. So I said stdin equals 0, stdout equals 1, stderror equals 2, sysread equals 0, syswrite equals 1, sysexit equals 60. And so when I actually down here do my hello world code, I don't need to remember those values because I just move into rex syswrite, move into RDI stdout, then down here I move into rex sysexit. So you can define constants like this using the EQU. So one last thing, I also want to look at including external files. So a single assembly program can be broken up into multiple files using include. Include will load an external file's code and insert it into the position in which it is included upon compilation. Macros and EQ definitions are often defined inside include files. So to use an include, you put %include and then put the name of the file to include in quotations. So as you can see, here's our hello world code, and I just say %include linux64.inc. Then I say section.data, defined bytes, hello world. Then I just, in my start, my actual code is just print text, then exit. This actually works. This is a fully functional hello world code. And the reason it works is because inside the include file, I've defined a print macro and I've defined an exit macro. So you can see linux64.inc at this link right here. Just go to that link and you can actually see the print macro, which I didn't show here, but it's basically just the subroutine from the print subroutine tutorial. I just converted that into a macro.